Now you could do both A and B using your skills from the past, using the idea of where these things are on a number line. Okay? I'm going to start off with even an easier positive question and an easier negative question. Okay, so before we get to A and B, I'll do preliminary question. If you had to find the distance between 2 and 8, wow. You wouldn't use absolute value bars at all, would you? You would just tell me the answer is 6. Okay, good. Because you would say, well, I know that 8 minus 2 is 6. Now, when you do the distance between -5 and -13, this one too, you might be able to just say it. What's the answer? What's the distance between -5 and -13 on number line? 8. Okay? But probably in this one, some of you might have just said, 13 minus 5, because I'm thinking on that side of the number line. And that side of the number line is the same as the positive side of the number line, so I could just do 13 minus 5 to find out it's 8. But then I'm not using minus 13 and minus 5 anymore. I don't think any of you set up this the same way, probably, because if you wanted to set it up the same way using the numbers, here we did the bigger number minus the smaller one, right? 8 minus 2. That's what you do with positive numbers. What do people mess up with negative numbers? Which is bigger, minus 5 or minus 13? The -5, which throws you off because 13 looks a lot bigger, right? It's even got 2 numbers and 5 only has 1. But minus 5 is bigger, so if I was writing this out, I would write minus 5 minus 13. And then minus and negative, same as adding. -5 plus 13, I get 8. And you say, well, it's a lot easier just to deal with the numbers I had to begin with. What happens with negative numbers is sometimes you do that. You screw up and don't have the right number first. If I had chosen -13 first and then subtracted -5, I would have got -8 instead of +8. And that wouldn't be the distance between the two of them. Because when we talk about distance, we're always talking a positive value. Distance doesn't have a direction. It's just a length. It's just a magnitude. It's always a positive value. So if you screwed up and put them in the wrong direction, you'd say, oh, -8. Well, I have to think of that as positive, and I could make that +8. What's nice about the absolute value bars is in either one of these questions, had you put absolute value bars around it to begin with, it wouldn't matter if you had the big one first and the small one next. You would get the right answer in the end. Because this would become absolute value of 8. And how far away is 8 from 0? 8. And this one would become the absolute value of -8. And how far away is that from 0? It's 8. Now those are using nicer numbers. When you get to decimals, again, don't worry about which one's bigger, which one's smaller. You can just use the absolute value bars. So I see -3.7. I write that one first because it's listed first. And then I subtract -8.5. to find the distance. I could go to my calculator and type this whole thing in. On a number line, here's 0. Here's -3.7. Here's -8.5. This is the distance that we're trying to find. And if we would type this into our calculator with the absolute value sign, exactly as we see it, oh, I hit the wrong button. Math, over to number, first one. If I took -3 and I subtracted, oh, what was it? Not -3, -3.7. And I subtracted -8. Point what? 5. Thank you. And push enter. It tells me that it's 4.8 as the positive distance. Right there. No problem. If you had to do this decimals, you could do this without a calculator, right? You could work with your decimals and add and figure that out and get 4.8 that way. I'm going to do B because it's fractions without our calculator, just to review your fraction rules. Okay? Again, I'll throw the absolute value out in front to find the distance, and then we'll subtract them. 4 2/3 minus -5, -5 3/5. The absolute values act as brackets. We have to do the inside of the brackets first, and then we can, once we get an answer, we can do the absolute value at the very end, which says if it's a positive number, it's going to stay the same. If it's a negative number, it's going to become positive. So I'm going to work inside these absolute value bars. First of all, subtracting a negative is like adding. So I've got 4 2/3 plus 5 3/5. Now, you all have methods for fractions that you remember. I've been, just teaching this last couple of days this same concept to my grade 9 classes. A lot of them are confused with it. Often with fractions, if you can go back to something that is a real life kind of example of it, it'll make it easier. I'm going to do that for you quickly right here. But first of all, how many people solve this by making improper fractions and then adding? So some people do that method. So I'll do the methods, then we'll bring it back to a real life example to help you sort of picture it better. So if you do improper fractions, remember 4 whole ones is 4 times 3 is 12, is 14/3 as an improper fraction, and plus 28/5. Then if you had this, you'll need a common denominator. So you'd multiply this one by 5 and 5, and this one by 3 and 3. We get a little bit bigger numbers without a calculator, but it's going to be both over 15. And we've got 70/15 here and 84/15 there, which leaves you with 154/15, which is 10 4/15. How many people use that as their adding fractions technique with mixed numbers? 2 people? 3 people? How many people use, with mixed numbers, doing them separate? Add my whole numbers together. 4 plus 5 is 9. Add my fractions together. 2/3 plus 3/5. Well, again, I have to get a common denominator, but here, my numbers are a little bit smaller, which is nice. 10/3, 10/15, sorry. 10/15 plus 9/15 gives me 19/15. 19/15 is more than 1, right? It's 1 4/15. So if I have my whole numbers 9 full ones, and then I have another 1 4/15, my final answer will be 10 4/15. That second method's kind of nice because you don't have those big numbers to deal with, but kind of not nice because you have to break up some stuff separately, and then sometimes things get lost. Okay? What I do with my grade 9s, and I'll get to you in a second, is these concepts for adding fractions, you guys now by grade 11, you know adding fractions, need a common denominator. Like those rules are so ingrained that you just do them, right? But it's good to always go back to like a reason. Why do we do these things? And what I do with my grade 9s is I always put this back to some real life example. If you had 4 chocolate bars and a bit, and had another, there's 4 full chocolate bars, and here's a bit. And then you added another 5 chocolate bars, and had a bit left over. This is always an easy question, because if you actually had your chocolate bars are always split up into pieces, depending on what kind of chocolate bar. Some of them have more pieces or less pieces, right? And when you open up your chocolate bar, you find out how many pieces are in a whole chocolate bar to begin with. And when someone asks how many chocolate bars you have, you would say, well, I have 9 full ones. That's sort of this technique here where we did the 4 plus 5. And then you would just count the pieces that are left. But when you're dealing with chocolate bars, you wouldn't say to yourself, I have 2/3 of a chocolate bar. You'd probably look at it and say how many pieces you actually have. And when you look at this one, you wouldn't say I have 3/5 of a chocolate bar. You would look at how many pieces you have. Now these chocolate bars, if you opened up a new one, 3 this way, 5 this way, would have 15 pieces in there. And this first bit, which was 2/3, which would be 2 this way, would be 10 pieces. And this one, which was 3/5, which would be 3 this way, would be 9 pieces. And it would be an easy question because you would say, I have 9 full chocolate bars and then another 19 pieces. But since every 15 is a full chocolate bar, I have 10 full chocolate bars and I'd have 4 pieces left over. And as soon as you think about something like this, it makes sense why you can't add this bit and this bit together as 2/3 and 3/5, because those are different sizes, and you can't add different sizes together. The reason we need a common denominator is so we're talking about things that are the same size, and that makes adding better. Another quick example where that works out well is if anybody wants more money, I have 2 5s, and I'm willing to trade for just 1 20. So then you'd have 2 bills instead of 1. That'd be a good deal, right? All right. So the questions you can do for this one are 5 and 8. I'll give you some time to work on the absolute value stuff. Probably the best ones to work on are those fractions ones.